Beautiful colours, fascinating patterns and variations. That's the world of Oriental Weavers, the largest manufacturer of machine-made carpets. In future, Oriental Weavers will be able to produce their carpets much more cost-efficiently. That's when the feedstock for the weaving yarns comes from Port Said, from the combined propylene-polypropylene chemical complex which Uhde has built on a turnkey basis. Design capacity, 350,000 tonnes per year. The customer, EPP, a company established under the leadership of Oriental Weavers. This is the first time that Uhde's STAR process has been applied on an industrial scale, and that's the reason for the unbeatably cost-effective production of polypropylene. But more of that later. The EPP complex was built on open land on the coast west of Port Said, erected on 2,300 piles that had to be driven almost 60 metres into the ground. A typical Uhde project, in which the Dortmund-based industrial plant contractor could bring all its experience and logistics to bear. At Uhde India in Mumbai, a team of up to 400 Indian and German engineers developed the basic and detail engineering and organised the international procurement. Their Egyptian colleagues in Cairo organised the building engineering and local suppliers. The office in Shanghai coordinated and supervised production in the Chinese factories. As always, Uhde sourced the equipment globally. For example, the order for the cold box was placed in the USA. The de-ethanizer and the C3 splitter came from South Korea. The giant columns were supplied in 25-metre-long sections and welded together on site. The erection of the 100-metre-long C3 splitter, which weighed almost 1,000 metric tons, was one of the most spectacular activities on the EPP construction site, and one of the most difficult. For safety reasons, the big lift was scheduled for a Thursday, the day the Muslim weekend starts.
Allahu Akbar, Allahu Akbar.
After midday prayers, most of the 4,000 employees had gone home. A 130-metre-high gantry was constructed in order to lift the C3 splitter. The hydraulic system at the top of the gantry pulled the column up centimetre by centimetre before finally placing it on a 10-metre-high concrete base. The whole operation took 2 days and went quite smoothly. Over the next few months, installation of the separation trays doubled the weight of the column. Owing to time pressure, this job had to be carried out simultaneously through a number of manholes at different levels. The C3 splitter is the final unit in the PDH process. It separates the propylene produced from the remaining feed gas propane, which is then fed back into the loop. A relatively high energy-thirsty loop from hot to icy cold, or more precisely from 580 degrees down to minus 110 degrees Celsius. The plant is packed with numerous heat exchangers, coolers and heaters in order to recover energy and to bring the gas to the required separation temperatures. At minus 110 degrees, for example, propylene is separated from the hydrogen. In addition, there are also very different pressure ranges in the process loop. Bearing all this in mind, the more effectively the propane can be converted to propylene, the more cost-efficient it is to operate a plant of this kind. The efficiency of Uhde's STAR process is currently unbeatable. Around the turn of the millennium, an Uhde team of scientists and engineers spent 6 years optimizing the process, and, at the same time, improving the platinum-containing dehydrogenation catalyst, which causes the propane to form propylene. After the team, in laboratory work, had also developed the downstream oxy-reactor as an efficiency booster, so to speak, the process was ready to be applied on an industrial scale. The STAR process is based on the use of steam reformers. In the fired heaters, tubes are heated from the outside to initiate the gas reaction with the catalyst inside the tubes. Uhde has a wealth of experience with this technology from building ammonia plants. However, the much shorter tubes with larger diameters in port side required a new technical approach. In addition, new ways had to be found to fill the tubes with catalyst. A test rig was set up at a specialist company in Rotterdam in order to check whether this simple trickle-sprinkle device lived up to its promise. And, surprisingly, it worked. Shortly afterwards, this simple solution was used to fill the reformers at EPP. It's a valuable material, this catalyst. So valuable that it's worthwhile recovering the platinum when the catalyst is replaced in a few years' time. The effectiveness of the catalyst is impressive. In the reformer tubes, 30% of the propane is dehydrogenated to propylene during every throughput. But that's only part of Uhde's unique STAR process. An oxy-reactor is installed alongside each of the two reformers. These act like boosters, converting another 10% of the propane, and thus obtaining 30% more propylene from the gas. In this patented process, oxygen is blown through numerous nozzles onto the catalyst bed in order to trigger the additional reaction. That was the idea for the chemical process. The problem was how to prevent the small catalyst granulates from being swirled away by the nozzles. Here too, a relatively simple solution was found. A guard net, woven to resemble protective gloves, such as those worn when cracking oysters. It's the use of oxy-reactors that constitutes the key economic advantage of the PDH plant built by Uhde. The propylene capacity can be achieved with 30% less catalyst, making the investment and operating costs unbeatably low. In this phase of the project, the suspense on the construction site is slowly becoming palpable. One after the other, the individual plant sections are commissioned. The customer is on site to check how things are progressing.
So we will come to the point that something is now mechanical ready, but we cannot commission it because it is not possible to do it in parallel.
So far, 60,000 cubic meters of concrete, 5,400 tons of steel and 6,500 tons of piping have been used. The final meters of what amounts to 1,500 kilometers of cable are being laid. During commissioning, Uhde's experts are at the same time also training EPP's operating personnel. And in the polypropylene plant, built by Uhde on the basis of the Sveripol process, licensed by LyondellBasell, some sections are also being commissioned already. Here, for instance, are the giant extruders, in which polypropylene will later be heated and extruded through fine holes. These rotating blades will chop the shock-cooled plastic into small pellets.
Main motor running.
With all the fine adjustments completed, the spaghetti run starts. First product. This too is just one of many small details in this enormous complex. In addition to the propylene and polypropylene plants, Ouda has also built a complete tank farm for propane, propylene, ethylene and hydrogen. A spectacular feat, placing the pre-assembled covers on the tanks. The product from the PDH plant can be buffered in the cryogenic tanks for a week, for example when shutdowns are necessary. The off-spec propylene is temporarily stored in a pressure vessel so that it can be reprocessed later. Naturally, this is one of the quietest areas of the EPP complex, with a few interruptions. The company's in-house fire brigade is carrying out an exercise. The brigade is part of a comprehensive safety package that Ouda has supplied with the two large-scale plants. In this case, lump sum turnkey means that Ouda is responsible for absolutely everything, including all utilities, from the water treatment unit and the cooling water system to the air fractionation unit and high-voltage electricity substation. Slowly, the PDH plant is starting up. The catalyst in the reformers and oxy-reactors is regenerated at specific intervals by adding air and steam to combust any soot that is caked on. At the moment, this is still easy to see as the steam vents to a bypass. Even in the startup phase, the product from the PDH plant achieves all guaranteed values, as can be seen from the continuous online analysis. There are only trace elements of ethylene and propane left in the propylene produced. The target 99.5% purity of the propylene gas has been achieved and meets the LyondellBasell specifications for the Sveripol process. At the same time, analysts in the fully equipped laboratory are looking for other trace elements. The gas samples, however, reveal the same result: unparalleled propylene purity. Plastic granulate tankers bring the polypropylene pellets to Oriental Weaver's carpet production premises in the industrial city 10th of Ramadan near Cairo. Fine yarns such as these are used to weave 150,000 square meters of carpet a day. Many of them will soon be made of polypropylene produced in the large-scale Ouda project in Port Said.